Okay, so today we're going to talk about balancing chemical reactions. So far, we've just talked about the basic kind of vocabulary of chemical reactions. We've talked about types of reactions. And now we're going to talk about why we need to balance chemical reactions. Okay, so according to the law of conservation of matter, the person that came up with that was Antoine Lavoisier. So why are chemical equations and balanced chemical equations so important? Matter cannot be created or destroyed. It can only change forms. It's conserved. So when we write equations, the number of each type of atom on the reactant side must be equal to the number of each type of atoms on the product side. So number of atoms of reactants equals number of atoms of products. That's for it to obey the law of conservation of mass. And that's how these reactions would happen in nature or if we did these reactions in a laboratory. Now, before we can balance, we need to look at one side of the equation. Now, we know we have subscripts here that tell us how many of that one single atom we have. It tells us we have 2 hydrogens and 1 oxygen and 1 molecule of water. And then we have this other term called coefficient, and that tells us how many of that entire molecule we have. So that 3 means we have 3 water molecules. So if I drew a water molecule and I had, let's say I had oxygen and it's bonded to the hydrogen, that would be 1 molecule of that. Well, if I add this number, this 3, this coefficient, what it does is it tells me I have 3 separate molecules. So in 1 molecule of water, I would have 2 atoms of hydrogen, 1 atom of oxygen, but in 3 molecules of water, I would have a total of 6 hydrogens and 3 oxygens. And I'd also, people draw these sometimes shorthand way of just, like that's an oxygen bonded to two hydrogens right there. So before we can balance, we gotta know how many do you have of each. Well, if there's a number in front of, like this 2, it's going to multiply by these other number of atoms. So in this case, hydrogen, I would have, in 1 molecule, I'd only have 2 hydrogens, but in 2 molecules, that would be 2 times 2, I'd have 4 hydrogens. And then 2 times 3, I would have 6 oxygens. Now, our next example, if I have 4, and that's iron 3 oxide, Fe2O3, well, I would multiply the 4 for a total number of irons would be 4 times 2. That would give me 8 irons. Then 4 times 3 would give me 12 oxygens. Next, if I had 6 NaCl, well, I have 1 sodium and 1 chlorine, so that would be 6 times 1, 6 sodium, 6 times 1, 6 chlorine. And then if I have NO2, if there's not a number here, it's just assumed there's just 1 of it. So that would just be 1 nitrogen and 2 oxygens. But let's look at another example. And you might want to write this down somewhere on your notes. If I have CaOH2. Okay, normally, remember, when I have something in parentheses, the number on the outside multiplies on everything on the inside. So in this case, I would have 1 calcium. I would have 2 times 1, 2 oxygens. And I would have 2 times 1, 2 hydrogens. Alright, so if I put a number in front of that, if now I have I would have calciums, there's only 1 of those, would be 4 times 1, I'd have 4 calciums. Oxygens, normally I would have 2 oxygens, but 2 times 4 would give me 8 oxygens. And then I'd have 2 hydrogens, but 2 times 4, it would give me 8 hydrogens. And let's look at one more. if I have five, if I have ZN3 PO4 in parentheses with a 2 on the outside. Now, normally I would have 3 zincs, but I can multiply that by 5, so that would give me 15 zincs. Normally the phosphorus, I got 1 on the inside of the parentheses times 2. That'll give me 2 phosphorus times 5, that would be 10 phosphorus. Then oxygens, I got 4 on this side of the parentheses times 2 on the outside, that gives me 8. And then multiply that by 5, that would give me 40 oxygens. And that's how you count atoms. You're going to have to be able to do that when we balance equations. Okay, so balance equations, in order to conserve atoms, you must balance the number and type of atoms on the reactants and product side of the equation. So if you notice in this reaction, CH4 plus, it's got a number here, 202. You know, it should be balanced. And what you could do is, you know, you could look at these molecules, you could draw them if you needed to help you balance them, but that's really kind of a long way of doing it. But if we counted all the whites, the hydrogens on the left, that would equal the hydrogens on the right. So we got 1, 2, 3, 4. 1, 2, 3, 4. The reds is our oxygens. We got 1, 2, 3, 4. And we got 1, 2, 3, 4. Then we got 1 carbon. It's black, 1 carbon. So that would be, you know, a balanced equation. So the coefficients here are going to allow us to balance these equations. Without the coefficients, it wouldn't be balanced. So how do we write chemical reactions? Reactions on the left, products are on the right of the arrow. Symbol shows what's happening. The arrow means forms or produces, and then if you see a G, it means gas, S, solid, L, liquid, AQ is aqueous solution, something that's dissolved. So if we look at this, does it look balanced? If you have H2, that's hydrogen gas. Remember, hydrogen is a diatomic molecule, so it exists as 2 atoms bonded together, plus oxygen gas, and oxygen is diatomic also, produces water. Well, looking at this, we have 2 hydrogens on the left, we got 2 on the right of the arrow, but then oxygens, we got 2 on the left, and we only got 1 on the right. So we need 2 more oxygens on we need 1 more oxygen on our right. We cannot go in here and do this. We can't go in here and change the subscript. When we do that, we've changed water into hydrogen peroxide now. H2O2 is hydrogen peroxide. We don't want to do that. We cannot do that. The only thing I can do is add a number right here. I can add a coefficient, you know, and I would need to add, and when I add a coefficient, that's going to give me a whole other molecule. So now I would have, if I add another oxygen, I have to add a whole new molecule of water. Now I got 2 of those. That would go there. And then I look and see if it's balanced. Well, it's not. Now I got 4 hydrogens. I'd have to go on the other side and put a number here because I need 4 hydrogens, and I would have to add another molecule of H2. That would give me 2 of those, and that would balance out this reaction. That's how this reaction happens in nature. If you were going to make, making water, it would take these numbers of molecules. 2 molecules of H2 would react with 1 molecule of O2 to produce 2 molecules of H2O. Now, and that's just going through and doing what I just now did. Okay, so in balancing equations, you're not allowed to change the chemical composition. You cannot change subscripts. Can't do that. You can only change the numbers of molecules on each side of the equation. You can only add coefficients. And those coefficients tell us the number of molecules. So the steps to balancing, you're going to count the number and top of each atom on both sides. If there are a different number of atoms on each side, you must add coefficients to compounds to change the number of atoms. Figure out what number to multiply each compound by in order to make the numbers of the atoms add up. And remember, you can never change the compound, you can only add coefficients. So some of you probably did this before in middle school, and some of you this might be new to you. So now here's an example. I would give you a chemical equation, and sometimes they're balanced. Sometimes you do not have to balance them. If they are balanced, you just write balanced in there. Some of them it's just a 1-to-1-to-1, ratio of molecules that you don't have to add any coefficients. But most of the time we have to do some balancing. So what we're going to do is make a T-chart. What I normally do is draw a line right down the middle, and I need the numbers to add up on both sides. And I'll write down what makes up the reaction. It's just two elements in this reaction. I got magnesium and I got oxygen, and I write that on both sides, magnesium and oxygen. And then I count the number of atoms on each side. On the left side of the arrow, my reactants, I got 1 magnesium, I got 2 oxygens. On the right, I got 1 magnesium and only got 1 oxygen. So my numbers are not balanced. They need to be the same on each side of the arrow. So I'm going to add coefficients. I got 2 oxygens on the left, I need 2 on the right. I cannot do this. That is wrong. If I do, I just change magnesium oxide into something else. I can only add a number right here. So I need 2 over here, so if I put a 2 here, it's 2 times 1 oxygen gives me 2 oxygens. But if you notice, I also changed my magnesiums. Now I have 2 magnesiums. So now I need to go to the other side and balance out my magnesiums. I can only put a number in front. I'll put a 2 right here. That will give me 2 magnesiums. And then I got 2 and 2, 2 and 2. That's the balanced equation for this reaction. Another thing we want to get in the habit of doing is every time we balance a reaction, we want to tell what type it is. So to kind of review on types of reactions, the first type is a synthesis reaction, and that's when you have 2 reactants and you only have 1 product. An example would be sodium reacting with chlorine gas to produce sodium chloride. You notice you only got 1 product. That would be a synthesis reaction. Decomposition, we usually use a D. So when you have 1 reactant, 2 products. If you notice you only have 1 reactant, it's always going to be decomposition. Water breaks down to form hydrogen gas and oxygen gas. It's decomposition. Third type is single replacement, and that's where I use SR to abbreviate that. So when you have an element in a compound on the left side and an element in a compound on the right side. So if you notice, sodium is an element reacting with magnesium oxide, which is a compound, produces sodium oxide, which is a compound, plus magnesium, which is an element. So I got my form on there. That would be single replacement. Double replacement is when you have on the left compound plus a compound. So you have 2 reactants, you have 2 products, and they're all compounds. So lithium chloride reacting with magnesium fluoride, producing lithium fluoride and magnesium chloride. They're all compounds. That would be a double replacement. And then last, combustion, and we can abbreviate that with a C, is when O2 is a reactant. CO2 and H2O are your products. Now, also you usually have a hydrocarbon, which is just what this is, something made of carbon and hydrogen. Sometimes it might have even oxygen there. You might have, that's still a hydrocarbon. It's made of carbon and hydrogen. O2 is always a reactant. CO2 and H2O are always products in a combustion reaction. So back to our example, if we had this one, we only have 1 product, so that's going to be a synthesis reaction. Okay, next example, we're going to balance it. We need to draw our T-chart. I know this reaction is made up of carbon and chlorine. I'll put that on both sides. and then I count the numbers. I got 1 carbon on the left, I got 2 chlorines on the left. On the right, I got 1 carbon, I got 4 chlorines. So it's not balanced. I gotta balance my chlorines. So I can only add a number in front here. What would make me have 4 chlorine, or excuse me, I go to the other side. What would make me have 4 chlorines? I've only got, right here, I'll need to add a 2. 2 times 2 will make me have 4. Then I check. Carbons are balanced, 1 and 1. Chlorines are balanced, 4 and 4. That is the correct equation, balanced equation for that reaction. And again, I have 1 product, so that would be a synthesis reaction. Okay, the one at the bottom, I have aluminum oxide breaking down to form aluminum and oxygen gas. I draw my line down the middle. This is made up of aluminum, oxygen, aluminum and oxygen. I count. On the left, I have 2 aluminums, I have 3 oxygens. On the right, I got 1 aluminum and I have 2 oxygens. So I can pick what I want to start to balance, I can start to balance this aluminums and put a 2 here, and that's going to make me have 2 of them. They're balanced. Now I got to look at oxygens. If I have come a situation where I got 3 on one side, 2 on the other, I need to find the least common multiple. The least common multiple of 3 and 2 is 6. So I need 6 on each side. That means on the right, I would need to put a 3 here. 3 times 2 gives me 6. On the left, I would need to put a 2 in front of the Al2O3 to give me 6 oxygens. But it's going to change my aluminums also. 2 times 2 gives me 4 aluminums. And now I have to go back to the other side and erase that to where I had 2, and I have to make that a 4. So my aluminums will balance. Then I check my numbers. That's 4 and 4, 6 and 6. So that is the balanced equation for that reaction. 2 molecules of Al2O3 break down to produce 4 atoms or molecules of aluminum plus 3 molecules of oxygen gas. And that would be, since I have 1 reactant, that would be a decomposition reaction. Okay, a few more examples, and today we're going to work some easy ones, and they're going to get progressively harder over the next few days. Okay, again, I need to balance this. I check it, and it's not balanced. And if it is balanced, I would just write already balanced. I wouldn't have to do anything. This is made up of phosphorus and oxygen. Phosphorus and oxygen. I got 4 on the left of phosphorus. I got 2 oxygens. On the right, I got 2 phosphorus and 5 oxygens. So first thing I can look at is just to balance my phosphorus first. I need 4 on the right side, so I need to put a 2 in front of there. That gives me 4 phosphorus, and 2 times 5, that would give me 10 oxygens. And remember, I cannot add a number in between a compound either. I can only add it at the very front. Then I go to the other side. What I need in front of the O2 to balance it, to make it have 10, I would need to put a 5 here. 5 times 2 is 10. I check my numbers. 4 and 4, 10 and 10. That's balanced. That's how that reaction happens in nature. P4 reacts with 5 molecules of oxygen gas to produce 2 molecules of P2O5. And since I only have 1 reactant, or 1 product, that would be a synthesis reaction. Now, on this last one, I'm going to balance it. I'll draw my line in the middle. Now this is made up of aluminum, iodine, mercury, which is Hg, and then chlorine. On the left, I have 1 aluminum, I got 3 iodine, I got 1 mercury, and I have 2 chlorine. On the right, I have 1 aluminum, 2 iodines, just 1 mercury, and chlorine I have 3. So when I look at this one, the way I want to balance it, we can start with our chlorines. If I have 3 and 2, then I'm going to need to make the least common common multiple of those, which is 6. So I want to have 6 chlorines on each side. If I go to the right, I would need to put a 2 right here. Now I have 2 aluminums. I have 6 chlorines. I go to the other side to balance my chlorines, and I put a 3 in front of there because I need 6. That changes that to 6, and then I have 3 Hg. Now I have to balance these. If I look, my iodines are not balanced, but that's 3 of 2. Balancing mercuries would be easier. So I got 3 on the left, I need 3 on the right. If I go put a number in front of here, that's going to be 3. It's going to change my mercuries to 3. It's going to change my iodines. 2, 3 times 2, 2, 6. If I notice my aluminums and iodines are not balanced, if I go, I got 2 aluminums on the right, I need 2 on the left, I need to go in here, put a 2, that gives me 2 aluminums, and then my iodines would be 2 times 3, which would give me 6, and that balances the equation right there. I got 2 aluminums on each side, 6 iodines on each side, 3 mercuries on each side, and 6 chlorines on each side. So that's balanced. The type of reaction is, you notice I have a compound plus a compound on the left of the arrow, compound plus compound on the right of the arrow. That means I have a double replacement reaction. So just make sure that every time we balance an equation, you also tell the type of reaction it is. Just get in the habit of doing that.